Hello, I'm Simon. Welcome back to my workshop, and in this video I'm going to tackle a problem that may well be familiar to you as well, and that's the one of trailing cables across the floor of your workshop. Now this is made a little bit worse for me by the fact that I also have cables for my video equipment and my microphones and so on. So to solve this problem I want to build a gantry system on the ceiling so that I can bring those cabled services from the ceiling rather than them trailing across the floor, thus reducing trip hazards. Let's get tinkering. So I'm starting with the boom arm because I think this is probably the hardest thing to build, and it'll be the make or break of the project if I can get this to work. Now my plan is to use these slatted boards. They were from a bed that I found in a skip. This part here will sit on the ceiling. There will be a joint here to move this arm up and down, and then a joint here to move this arm up and down. The key thing that I need to control and test is I need to be able to put about 2 kilograms of weight on the end. At the moment I can't even put a little bit of weight on. This here is 1¼ kilograms, and you can see it can't hold it. So I need to find a solution that will allow me to hold weight without the arm then moving. At the moment it holds itself, but it doesn't hold any weight at all. Even a little finger can move it. And I do have some things that I want to test, and I'll explain those next. And I thought I could supplement the bending with some springs that pull taut. Can't even move that on. Let me just give you an example. Some springs that basically open up as the arm bends, thus providing a little bit more friction. Now these aren't really that strong. This one though is incredibly strong. I can't move it at all, but I'm sure once it's fixed then that pulling motion will just give that arm a little bit of extra tension where it's needed. And I was thinking I also have these 2 springs, and it looks like these are actually compression springs, but I'm going to convert them to springs like these so they can be used in expansion, and I shall put these on as well at the back. So I'll have this on the first joint, these 2 on the first joint, and this one on the middle joint. So expanding on this idea of using the spring a little, I think what I'm going to do is cut out a little bit of this board so that this spring can lay in here and be flush with the board. I can then put a bolt across here between these 2 pieces, and then as I bend this, that bolt will want to pull this spring, but it'll be fixed at this end, and therefore it will have to expand in order to bend down. And I'm hoping that this spring alone will provide enough tension that I can actually put some weight on the end. We're only going to know by testing it. I've adjusted my pillar drill table and the stop on the fence so that I can get a hole in exactly the same place on all the boards. This auxiliary table is so useful and it's really easy to make. I'll leave a link to a build video in the description. Having piloted all the holes, I followed up with a larger drill bit. Okay, so this is surprising. I've drilled the hole and put a bolt in, and as soon as I tightened the bolt I can still move this about, albeit it's quite stiff. But what I found, this is 2½ kilograms, and this is another 1¼ kilograms, taking us to 3¾ kilograms. That's about 8 pounds, and you can see 8 pounds and it's going to move, but 2½ kilograms, that's about 5 pounds, it's fine, and that's right on the very end. So I'm going to keep the spring idea in my back pocket. I can always add it later if I find that this isn't working well enough, but for the moment I'm going to go with just the bolt tightened to an appropriate level. For the joint at the back of the boom I'm going to need to cut 4 7-inch pieces. The exact dimensions aren't too important, but they need to be about 180mm or 7 inches long. I'm using the sub fence as a stop. Now this could potentially be dangerous, but because I've put the sub fence in front of the blade, the wood can't be trapped and therefore I can't get kickback. I piloted the holes for the back joint, then enlarged the holes with a cordless drill. I'm going to return to the spring idea for the back joint at least, because whilst I can tighten this enough for it to hold 2 kilograms, 4 pounds down at that end, I then can't move it at all. And there's a balance between having this and this so that they can both be moved around whilst holding the weight down that end. And if I tighten this one too much, then only this one will move. If I loosen this one, then this one will move and this one won't. So there's a bit of a balance in tightness to get this so that I can move both parts so that it can articulate properly. I drill 4 holes for a bolt which will hold the springs. This will make a lot more sense when I come to assemble it. I cut out a section for the spring to sit in. Let me just show you what I've done with this spring. So here's one I haven't modified, and then here's one I have modified. The holes are at 90 degrees to each other, and that is necessary for the way that I want to mount these. It was a bit too difficult for me to make this modification on the spring, which was just done with pliers really, but it was difficult to video, so I'm just showing you the end result. With the springs sitting in place, I can hopefully show you now exactly how they're going to work. These 4 pieces are going to be connected by this rod and it's going to thread through these springs. The back of the spring is going to be connected to these 2 pieces, so when these move in conjunction to that, it will pull on these springs, providing a little bit of extra tension. I'm going to fix the springs at the other end using a washer and some particularly long screws. I've already piloted the hole, so hopefully the wood won't split. I'm just using long screws because I think there's going to be quite a lot of pressure on the springs and I don't want the screws being pulled out by the spring. I was trying to work out why this now wouldn't move, and I thought it was perhaps just the tension in these springs. So I pushed a bit harder and then I realised that the back here actually is fouling this bolt here, so I need to just take the backs off these so they don't foul the bolts. You can see that's what's happened here. It's hit the bolt and pulled it up. So I'm going to take it apart and just remove the corners from these so that the bolt doesn't foul. Okay, I'm going to have to do a bit more research. Whilst I can tighten these bolts and the bolts at the back so they're tight enough to hold a 2 kilogram weight, that's 4 pounds, on the front, I can't tighten them so that I can move these physically at both ends. If I get them to the point where I can actually physically move them, then this won't take any weight at all. So there's something fundamentally wrong with the design, which I guess I probably knew deep down it wasn't going to work. So I'm going to have another think. I have to read up on designs of these sorts of booms, and I'll have to have another go in part 2. Well, I know this was a fail, but hopefully in the next part we'll see some improvements and I can move on with this boom and get it to a point where it's actually doing the job that it needs to do. If you've enjoyed this video, please leave a thumbs up. If you'd like to see more videos like this, then please subscribe, and I'll see you in my next video. Thanks for watching.